Hey, it's Bruno here. It looks like you have your computer all set up. That's great to hear because we have our first client. They're a car manufacturer and they have some data on cars that they need to figure out. But there's just too much mess out there. They don't really understand how to read it. I heard you're good with data analysis, so I'm going to hand this off to you. Don't let me down. This is your first task. I'll see you later. All right, everybody, there's another task that Bruno gave us. We have to analyze and do some data analysis on some car data. Now, throughout the next couple of sections, we're actually going to get our hands dirty and start using Jupyter Notebooks and start coding. We're going to use Python, we're going to use Pandas, and we're also going to use something called Numpy. Now, a bit of a heads up here. The way we've structured these sections is that you should code along with us. So make sure you have your Jupyter Notebook open and you code along and write stuff in as we have as well. We'll also provide all the notebooks and worksheets for you. And at the very end of each section for Pandas and Numpy, we actually provide exercises based on what you've watched and what you've learned. So don't worry if you find some parts confusing, because these are pretty tough topics to understand at first. But by coding along and then doing the exercises at the end of each section, you'll notice that things start to stick bit by bit. Remember, we're learning these things because they're valuable. They're skills that are valuable. And valuable skills don't necessarily mean skills that are easy. If you could just watch videos from your couch and not practice and become a data scientist, well then everybody would be a data scientist and everybody would have high salaries. But that's not the case. We need to work and practice to really understand these things. So just giving you a warning, if it becomes a little tough, intimidating at first, remember this, every time something is difficult, that's what makes a skill valuable. So practice with us as you code, and also make sure you do the exercises at the end of each section because they'll help stick that information that we've learned in the videos. All right, enough talk. We got to figure out this car sales data. So let's get to it.
Welcome back, everyone. And now I'm so excited for this series of videos as well because we're going to talk about pandas. I wish I could give this guy a high five in real life. How beautiful of an animal is this panda? Now, the thing about pandas is they've usually got black ears with white face, and some of them have black around their eyes. But in rare cases, you'll get different patterns of black. No, I'm kidding. We're not talking about the animal pandas, but that would be pretty cool. We're talking about the data analysis library pandas. Now, if you're doing machine learning or data science in Python, you're going to be using pandas, and it's used to explore data, analyze data, manipulate data, get it ready for machine learning. So that's what we're going to be focused on. So if we revisit our framework, we've got this data modeling section here. We've been through these steps. Now we're going to really start to get into some of the tools that we can use. So let's change this up a little. We've still got our framework up here, but now we're starting to dive into these tools. We've covered Jupyter Notebooks. We've looked at Anaconda and Miniconda. We've set up an environment using those. Now we're going to start diving in to doing data analysis first with things like Pandas, MatPlotLib, and Numpy, and then later on we'll look at some machine learning. But for now, we're focused on Pandas, which is usually part of these three steps here, the data analysis section. Now, why Pandas? Well, first of all, it's simple to use. It's integrated with many other data science and machine learning Python tools because that's what we're focused on, right? We want to find machine learning and data science tools in Python and use our knowledge of Python to use those tools to gain insights out of data and build machine learning models. And oftentimes you'll get your data in a format that isn't quite ready for machine learning. The data is there, but fairly often you have to go through a few steps to make your data in a format that can be inputted into a machine learning algorithm. And so that's where Pandas comes in. It helps us take a raw table of data. Raw data means data that you've just gathered, and then manipulate it, ready so you can use it with machine learning algorithms. So what are we going to cover in this section? Well, because Pandas is so vast, it would take quite a long time to look at the entire library. So we're going to be focused on the most useful functions, things that you'll use basically in every data analysis that you do. We'll look at the different types of Pandas data types. There's two main ones, series and Dataframe, but we'll look at that in a second. We'll look at how to import and export data using Pandas. Different ways you can describe your data. So if you just imported some of your data, how can you describe that statistically? Like what is the average value of a certain column, etc. Pandas is so beautiful in that it allows you to view and select your data in almost any way that you can imagine. So if you can think of it, you can probably do it in Pandas. And then finally, once we've described our data, once we've seen it, once we know how to select it, we'll look at how we can change it up and manipulate it. We can massage it into a format that's ready for our machine learning algorithms. So I think it's important before we actually start to jump into doing the actual code is to remember where you can get help. As we go through these videos, follow along with the code in a Jupyter notebook if you can. If you can't, while the video is going, don't worry. Just watch the video, watch it as I go through it, and then go through it on your own after the video's done. It's very important to try and just write the code yourself. If in doubt, just run your code. And don't worry if an error pops up. There's different places you can look, such as Stack Overflow or Pandas documentation to figure out what's gone wrong. The most important is to try for yourself and then to try it again, because this is what will help you learn. So if in doubt, run the code. And then if you're still stuck, don't forget, it's always okay to ask a question. There's never a silly question. That's an overview of what we're going to cover, what Pandas is, where to get help. Let's dive in and start coding. Now we've got a little bit of an overview of what Pandas is. Let's start to code it. So to begin, we're going to load up a terminal or command prompt. Now this is the workflow we've been through a couple of times now, but we're going to keep going through it with each new concept to make sure we kind of get it down pat, because that's what we're doing, right? We're just practicing and practicing and practicing. So if we try to access Jupyter Notebooks, which is our workspace where we want to use Pandas, if we run this code whilst we're in the base environment, it's not going to work. So we need to activate the environment that we've created. So if I go conda env list, this will show me my environments. And in my case, I want to go to the sample project folder that we created in the beginning, because that environment has all the tools such as MatPlotLib, Pandas, Jupyter, Numpy, etc. We're focused on using Jupyter and Pandas in this section. So to activate that, I'm going to type in conda activate. Then I could copy this here and put it down there, but we're going to practice typing out commands in the command line because that's what you want to get proficient and used to typing these sort of things. ML course sample project /env, and we'll hit enter. So now that has activated this, and you can see we've changed from base to having this environment activated. So if I load up a Jupyter Notebook now, by typing Jupyter Notebook, it's going to open up my browser. Beautiful. Now, because I'm in my home directory, I need to look into my desktop and then ML course, sample project. There we are. So now we're in the sample project folder within the Jupyter dashboard. Now this is the project that we made in before, in a previous session where we created example notebook. So to begin exploring Pandas, we're going to go new, Python 3 notebook. We'll give this a name. We'll call it Introduction to Pandas. There we go. Hit enter. And so, to begin with Pandas, the first step is to import Pandas as PD. We've seen this a few times already, but this abbreviation PD is just a short version of Pandas. It saves us from having to type Pandas continually. So we'll hit Shift and Enter. And this is just going to tell Python, because we're running Python 3, hey Python, go and get the Pandas tool for us because we want to use it. And now the first thing to know about Pandas is there's two main data types. I'm writing that little hash, this is a comment, and I'll hit enter. The first one we're going to look at is series. So if we go series equals PD series, and now remember, where the style we're gonna go through these concepts is by looking at them first before discussing them. Because remember, if in doubt, run the code. Now if I make a series here, the command pd.series takes a Python list. So I've got a few car brands in there, so we could really call this car brands if we want, but we'll leave it as series. So let's hit Shift and Enter. And to view our series in Jupyter Notebook, we'll type in series, hit Shift Enter. So now we can see we've got like a single one-dimensional column of information. And that's the main thing you need to know about series. So series equals one-dimensional. So one column. Let's practice making another one. We'll hit Escape and create a new cell. So what about this one? We do some colors. Colors equals pd.series. We'll go red. We'll go blue and white. Excellent. So if we go underneath here and we'll put colors underneath so it displays it. Shift Enter. Beautiful. So now we've got two 1D series, one-dimensional, when I say 1D by the way, one of car brands and one of different colors. So now the difference between a series and a data frame, now a data frame is two-dimensional and data frame is far more common. I'm saying column because data frames have columns. A data frame is far more common than a series, because oftentimes with your data, you'll have more than just one single column. So let's create a data frame. We'll call this one car data maybe. Car data equals pd.dataframe. And now dataframe is a little bit different because it takes a Python dictionary. So I might go car make. And then the beautiful thing about data frames is that we can create a data frame out of series. So we've got series here. So car make, this is the key, and this is the value. We'll go color. And we'll give it our colors series. So down here, we'll go car data. Beautiful. That is our first data frame. Now this is so exciting, right? Because I love data frames and it's a beautiful thing to start seeing your first ever data frame being made. And now, if you have a look here, making a data frame from scratch can kind of be a bit tedious. So what you'll usually do is rather than creating your data frame from some series, you're going to import data. So we'll type that down here, import data. And now, where would you get data? Say, for example, we wanted some car data. Where could we find that? Well, if we go up to this beautifully created, pre-made spreadsheet, and by the way, all the resources to what we're working on will be in the resources section, we can see that this is a spreadsheet called car sales. And now, how do you think we might get this into a Pandas data frame? It's all right if you don't know the answer, we haven't been through it yet. But this is what Pandas is great at doing, right? You'll have some structured data, maybe in a spreadsheet or something, which could be anything, right? This is car sales, but you could have transactions, you could have patient records, something like that. But we want to, rather than manipulate the data in a spreadsheet, we want to start using code, specifically Pandas code. So the first thing is we have to import it. Now, for this car sales data, the way we could do it is to export it. Now there's a little download tab here into comma-separated values, .csv. Now this is a very common data storage file type, and Pandas works beautifully with it. So if we were to export this spreadsheet data as comma-separated values, let's do that. That's going to save down here. Now I've already imported this into my sample project folder as carsales.csv. So let's see how we would import that in Pandas. So car sales equals pd.readcsv, and then we're going to type in the file name as a string. So carsales.csv. Now the beautiful thing about Pandas, or Jupyter Notebooks in general actually, is that you can use tab autocomplete. So let's try that out. So we're going to press tab. There we go. And we've got some options here that's going to pre-fill that. So we don't want the missing data one. We'll have a look at that in a future video. But let's click that. There we go, carsales.csv. So all this is doing is saying, hey, Pandas with PD, read this CSV file and save it to car sales. So we'll hit Shift Enter. Now let's have a look at that data frame. Beautiful. So now we can see this is just the exact same information that's here in a Pandas data frame. Now, the beautiful thing about this is that because it's now in a Pandas data frame, we can take advantage of all the functions that Pandas has to offer in manipulating, viewing, and changing this data. All right, let's have a quick overlook of what the anatomy of this data frame is, because different places refer to different things. So we'll go to this slide, the anatomy of a data frame. So we'll break it down. On the left-hand side is the index column. Now, Pandas data frames, like Python list, start at 0. So if you had 5 rows in your data frame, it would only go up to 4. Remember, it starts at 0. Now, this here is a row. So all these values here, including the index, is called a row. And these ones here are columns. And a row is referred to as axis 0. And a column is referred to as axis equals 1. So if you ever see a Pandas function in the future, which has a little parameter called axis, if it's saying axis equals 0, it's meaning a row. Now, if it's saying axis equals 1, it means a column. I got confused by this in the beginning. I was just like, just tell me if it's a row or column. But some functions use axis 0 or axis equals 1. Now, these individual values here are data. You can have different kinds of data types. We'll see those in a future video. And the headings up here in bold are column names. So these are the main things you need to know about a Pandas data frame. You can take a screenshot of this or something like that. It'll be in the resources section as well. But if ever you hear me referring to different terms around here, you can always have a look at the anatomy of a data frame and know what's been talked about. So let's go back to our notebook. And so once you've imported a data frame, what you might want to do is make some changes here and then export it. So let's see how we would do that. Exporting a data frame. Now, of course, we haven't made any changes to ours just yet, but we're going to export it anyway to see an example of how to do it. To export a data frame, we take the variable of the data frame, carsales.toCSV. So to import it was read CSV. Now we're going to call this function carsales.toCSV and then pass it a string name of what we want to call it. Import exported carsales.csv. Now you could also do carsales.toExcel if you wanted to export it to an Excel file. But since we're only really working with CSVs, which is kind of a universal data type, you might not have Excel on your computer. CSVs you can run almost anywhere. We're going to export to CSV. So if we hit Shift and Enter, where do you think that's going to go? Let's go back up here. We look in here. Exported carsales.csv a few seconds ago. Beautiful. So now if we wanted to create a new variable, exported carsales, just to demonstrate, pd.readcsv carsales. No, we want to go exported carsales. So all we're doing now is just re-importing this file here to see what it looks like. And then we'll go exported carsales. We'll fix up this one as well. Shift and Enter. Beautiful. We import it back in, but there's some unnamed column here. Now this is a little trick of what toCSV does. Because there's this index column here, if you don't put in index, I think it's equals false. If you don't put in this, it'll export it with the index as a column. So let's see what happens if we go there. Index equals false. Now we're going to, all that's done is re-exported the file. Then we're going to re-import it. There we go. It's going to index it as it gets imported. So that little parameter there, index equals false, is go export this data frame and don't worry about throwing the numbers there. But I think that's enough for now. We've looked at the main takeaways from this is that Pandas have two main data types, series, which is a one-dimensional column. So there's only one column here. Dataframe, which is the far more common type, which is two columns, or two-dimensional, sorry. So you've got rows and columns. But the more common way of importing data into Pandas is to read something like a CSV file. And then once you've made changes on this or manipulated in some way, you can export it as a CSV file. All right, I'll see you in the next video. Okay, welcome back. Now in the last video, we went through different data types in Pandas, series and data frames, creating some series in a data frame, importing data, and then exporting data. Now we're going to look at different ways you can describe data in Pandas. So we'll make a little heading here. Remember to do that. You can type some Markdown. If you've never seen Markdown before, you can do some research. But to create a heading, you can do two little hashtags, and this we'll press Escape and M, Shift Enter. Now we've got describe data in a nice little heading format. This is a great way to break up Jupyter Notebooks so it's communicative. Okay, so the way you call functions, we've already seen this on an example here, to CSV on Pandas Data Frames, is by pressing the dot notation. So if we go tab, it might show us, there we go, took a little while and I got impatient and pressed tabbed a lot. It'll show us a few functions here that we can run, but remember there's a lot here. So in the beginning, don't focus on trying to learn all of these off by heart. Just focus on using the few that we're going through at the moment and then build upon your knowledge as you go. So the first thing we're going to have a look at is how to describe the data types in our data frame. We can do this by typing in D types. So you'll notice some functions have brackets after and some don't, like this one doesn't have brackets over it. The difference between these two is this is an attribute. So we type in here attribute, whereas a function like car sales to CSV is a function. So the difference between an attribute and a function is this is going to perform some steps, whereas D types, which is an attribute, is just some meta information which is stored about the car sales data frame. So that's the two main things to remember here, the difference between an attribute and a function. We don't want to run this line of code, so we'll comment that out, but we do want to see the D types. So let's do that. Hitting Shift Enter. Now this will tell us some information about our car sales data frame columns. So it's got a make column. Let's view it up here. Make, color, odometer, doors, price. That's our column names. So this is going to tell us the type of our make column is an object, color is an object, odometer is an int, doors is an integer, and price is also an object. Let's have a look at some other things we can do with our data frame. Carsales.columns. Now, is this a function or an attribute? It doesn't have brackets, so it's an attribute. So this is going to tell us our column names. It's going to return it as a list. So you could go car columns equals carsales.columns. Hit Shift Enter, and now you've got your column names stored as a list. So you can perform some operations on this list and then use that later on to manipulate your data frame. But this is just how you access two of the main types of attributes from your data frame. Let's have a look at something else. What about the indexes? So we go car columns.index. Has no attribute index. Oh, because we typed in car columns, we want our car sales data frame. There we go. Beautiful. So this is going to say, let's view the data frame here, car sales. This is going to say the range of the index starts at 0 and stops at 10. Step is 1. So 0, 1, 2, 3. Okay, that makes sense. Now we've gone through a few different attributes of our data frame. Let's have a look at some of the functions we can call. Remember, the main difference between a function and an attribute is one doesn't have brackets, attributes don't have brackets, and functions are going to perform some kind of operation. So the first one we'll have a look at is describe. Now there we go. What describe does is gives us some statistical information about our numeric columns. You might notice why isn't price coming up here as a numeric column? So we've got odometer. That means there's 10 columns as count. The mean is 78,601. So the odometer is how many kilometers a car might have done. And then number of doors, the count is 10, meaning there's 10 rows with doors as a column. And the mean is 4. Standard deviation is that 0.471405. We've got percentiles here, min and max. But no price. Well, if we come back up here, we can see that the odometer is an integer value and the doors are also an integer value, but the price is an object. Now that's interesting. Maybe when we imported it from our CSV, this cell is formatted differently to these cells. Don't worry, we'll have a look at that in a future video. But something to keep in mind is that describe works on only numeric columns. So let's have a look at something else. Maybe we want info. Carsales.info. And now it's important to remember that these type of description functions and attributes are some things that you might run through at the very start of exploring a new set of data. So that's what we're doing. We're pretending we've got car sales here, and we want to start running functions like info and describe to just start exploring our data and getting some information about it. So what's this going to give us? Let's have a look. Range index, 10 entries, 0 to 9. Now, info is kind of like index combined with D types. And so remember, Pandas has many different ways to do similar things. So as you go through and work through, learn more about the library, you'll kind of find a pattern that works for you best. I'm just showing you a broad collection of different useful functions you can use throughout any type of data analysis. What this is going to tell us is that the make column has 10 non-null objects, 10 non-null objects for color, same again for the rest of the columns. There's 2 D types for int64. Yep, that makes sense. int64, int64, and 3 for object. Okay, and it's not using very much memory. All right, let's keep going. Car sales, you can call statistical analysis on your data frame. So car sales.mean will give you the average of your numerical columns. Remember, price doesn't show up here because it's an object, not a numerical column. You can even call mean on individual series. So let's make a series called car prices equals pd.series 3000. Let's pretend that this is our car prices, that they're not in object format, they're in integer format. And then we go car prices.mean, car princes. I wish I was a car prince. There we go. So that's going to give us the average of these 3 numbers here. So it's pretty high there, 38,583, because we had this big value. That's a car prince car right there. Next one we can have a look at is sum. So we can go car sales.sum. This is going to sum up all of the different columns values. So this is just really combined what's in the make column, what's in the color column. It's totaled up how many odometer there is, how many doors there are. It's not really useful calling it on the whole data frame, so maybe we do it on a single column. Now to select a single column, we'll go through this in the selection video, but to select a single column, just to demonstrate it here, doors.sum, you type in the name of the column in square brackets as a string, and then call .sum, hit Shift Enter, and now that's just going to bring the sum down here. Now you can do a fair few different versions of this statistical, like not just sum, you can go mean, median, and a bunch of others. So I'd suggest if you're practicing, try out a few different statistical functions. Even look up the Pandas documentation for different statistical measures you can call on different columns. And then finally, if you want one last bit of information about your data frame is length. So the reason you might want this is, say your data frame's 200,000 rows and you only wanted to work on a few thousand for an exploratory data analysis, you could figure out the length of the data frame you're currently working on by passing it to len. And we can see that there's 10 rows in our data frame. We have a look at it one more time. Beautiful. And that's nice and correct. Okay. So that's the end of this describing section. what you could probably do is go through, practice running the code yourself, and then see if there's any other functions here that you want to try out. Maybe create your own series like this, and then see what statistical values you can find out about your series. But without further ado, I'll see you in the next lecture, and we'll look at how to differently view data and select data. Welcome back. Well, we've had a look at a few different ways of describing data that we've imported to Pandas and into a data frame. Let's have a look at a couple of different ways we can view and select data. So we'll come down here, we'll put another little heading in. So we go viewing and selecting data. We're going to hit escape and M for markdown, shift and enter, because we're keeping our notebooks nice and clean and communicative right from the beginning. So to begin, one of the first things you'll do is have a look at the head of your data frame. And now remember, this has brackets after it, so it's a function. And what this is going to do is return the first or the top 5 rows of your data frame. Now you might be thinking, why 5? Well, that's a good question. I'm not entirely sure. But 5 seems like a pretty good number. And so in practice, what you'll probably be doing is manipulating your data frame in some way and then calling head on it fairly often, so you don't have, now our data frame's only 10 rows, so calling the whole thing isn't actually too bad. But imagine if you had thousands of these. So what head does is it gives you a quick snapshot in a small little space of what your data frame contains. So if you make a couple quick changes here and there, you might want to look at the top 5 rows. And if 5 isn't enough, maybe you want to look at the top 7. Well, the beautiful thing about head is that you can type in a number here and it will return that many rows. So you can have a play around and return whatever amount of rows you want. Now, for some reason, if you wanted the bottom of your data frame, you can use .tail, and that will return, you might have guessed, the bottom 5 rows. Now, this is handy if you're doing some alterations on the bottom of your data frame rather than the top, and so the changes will only appear towards the bottom, something like that. And tail's much the same. You can put in any kind of number you want here, press shift and enter, and it will return the bottom 3 rows there. Now, the next 2 functions that we're going to look at are lock and ilock. So let's write them down here, lock and .ilock. Now, before we go into the details, remember, we always want to run code first. If in doubt, run the code. That's our motto. So let's create a series here so we can demonstrate the difference between lock and ilock. So I'm going to make one called animals. What's your favorite animal? Maybe, since we're using pandas, maybe we'll put a panda in there. And one more, snake. Now we're going to set the index here. Now, if we created a series, by default, the index will be 0 to however many things we have here. But let's actually see that rather than talk about it. Because remember, if in doubt, run the code. Animals 0 to 4 in order. But if we wanted our own custom index, which we can do by passing the index parameter, and then we put in a list to say 0, 3, and we want this index to be out of order on purpose so we can demonstrate lock and ilock. There we go. So we have 5 things here, 5 things here, both Python lists. Now if we run this, we can see that our index has changed. So let's have a look. Animals.lock 3. If we call this, what do you think will come back? And lock you can consider as short for location. So let's try. Shift enter, dog, and snake. Beautiful. So what lock refers to is the index numbers. So because we have 3 and 3 here, it returns 2 items. Let's try animals.lock 9. What do you think this will come back with? Which animal? Shift enter, bird. The reason being is because bird is at index 9. So we created bird, 1, 2, 3, 1, 2, 3, index 9. Okay, now let's try our car sales data frame. If you're not sure what this looks like, we'll run it here. So we can see, okay, 0, 1, 2, 3, the index is still in order here. Beautiful. Now let's run lock on this. cars.lock3. What do you think this will come back with? Which car? Let's try it out. Oh, beautiful. Comes back with position 3. A beautiful black BMW for $22,000. It can be all yours. I could become a car salesman. What do you think? So now let's try another one. Let's try iLock this time. We'll put iLock here. So we go animals.ilock3. This time we're doing .ilock instead of just lock. So if we have 5 items here, what do you think this will come back with? Let's try it out. Shift Enter, Panda. Now, so we can see it, let's put a new cell here and go animals. Beautiful. So what iLock refers to position. So we can see here, 0, 1, 2, 3. If this was in order, remember, Python lists and data frames and series start from 0. iLock refers to position, whereas lock refers to index. Let's try maybe with our car sales data frame, carsales.ilock3. It comes back with the same as lock. That is because if we go up, actually, let's just do it here. Car sales. If we have a look at our data frame, iLock, position 3, remember because iLock refers to position, so 0, 1, 2, 3, is the same as index 3. So that's the main 2 points you have to remember about iLock and lock, is that iLock refers to position, and we'll put in here lock. Lock refers to index. They're the main 2 differentiations there. Okay, now the beautiful thing about this is that with iLock and lock, you can use slicing. So if you've ever used Python lists, you might be familiar with slicing, but if not, I'll show you what that looks like. So we might type in animals.ilock:3. And what this means is, rather than talk about it, let's run the code, is give us the items in animals up to position 3. Now, iLock doesn't include position 3. So it'll give us, remember, start from 0, 0, 1, 2, 3. So it's going to give us up to 3. Now let's try it with the car sales data frame. carsales.lock:3. Shift and enter. There we go. It's given us up to and including index 3. Basically, this is the same as calling head, but with 4. So carsales.head 4. Excellent. Okay, let's keep going. Now, we've seen this previously, but let's say we wanted to select just this make column and have a look at what's going on there. So the way to select a column is to type in its name in square brackets next to the name of the data frame as a string. Shift enter. There's the make column. Let's have a look at the color column. Car sales, color. Excellent, we've selected that. Now there's 2 ways you might see. I want you to be familiar with both of these ways of selecting a column. So if we go carsales.make, it's easier to type than something like that, but this is the same thing. Let me demonstrate. Carsales make. These 2 lines of code are going to do the exact same thing. Let's prove it. I'll put a split in here by hitting Control-Shift-. We're going to go make. Excellent. And we're going to go carsales.make. Now, the only real difference between these 2 is the syntax. So whichever one you prefer, you might want to use. But what you should know about the dot notation is that if your column name has a space in it, the dot notation won't work. So if we try to do this for odometer km, it'll come back with an error. But if we put a cell in here and go car sales odometer km, run this, it'll return the odometer. So they're the 2 main differences between selecting a single column. And now, one last thing before this video gets too long is that if you wanted to select a single column but put a little bit of a filter on it, let's do it with the make column, but we only want rows with the car make Toyota. So can you decipher what's going on here? We're saying car sales, okay, and then we're passing it this little condition here. This is called Boolean Indexing. Let's hit Shift-Enter to have a look. So this is going to say, hey, Pandas, give us a car sales data frame, and this condition is I only want the car sales data in the make column, which are equal to Toyota. Now, what if we only wanted maybe those with over 100,000 kilometers on the data, on the odometer? We've got data on the brain. That's why we're saying it. Let's get odometer here. KM, because remember, we can't do the dot notation. So you can create a habit which one you want to type. Usually you pick one way of selecting a single column and stick with that throughout your entire notebook. So we want greater than 100,000. Now, this is going to give back the rows that fulfill this condition. And so you can imagine how advanced you could get with this. If you had, say, 100,000 different cars, you might put in a few more different criteria in here. But this is just a few simple use cases of how we can view and select data. Now, there's a couple more we're going to go through, but to prevent this video from going for too long, we're going to take a little break, go back over what we've gone just through and practice a little bit before the next one. But otherwise, we'll see some more ways of selecting and viewing data in the next video. All right. We're making some real progress here. There's almost an infinite ways that you can view and select data with Pandas Data Frame. We're only really scratching the surface here, but once you learn these foundation steps, you can really combine them in kind of any different way you can imagine and really transform and view your data in a different light. So let's keep going. We're still viewing and selecting data at the moment. So the next one I want to show you is PD Crosstab. This is a great way to compare two columns if you want to see them like a little innovative, is that the right word? I'm not sure, doesn't really matter, but you'll see. A little comparative way, maybe that's a bit better word. So Crosstab is basically going to say, hey, Pandas, grab the make column. Let's refresh our memory of what our data frame looks like. We have make, which is car makes, doors, which is here. So this is going to cross over the make column with the door column. And so crosstab is you call pandas.crosstab and you pass it one column and then another column. So we got here, these are doors, the amount of doors, 3, 4, and 5. So we've got 3, 4, 5. And these are the different makes here. We got 4 different makes, Toyota, Honda, BMW, and Nissan. Beautiful. And so what this is doing is it's kind of aggregating these two columns together. So let's explore this. BMW, there's one car with 5 doors. Honda, there's 3 cars with 4 doors. Toyota's the only car brand that has 3 doors. I'm not quite sure what that car would look like, but who knows? This is kind of data you'll come across. Okay, now Crosstab is great for comparing 2 columns, but what if you wanted to compare more columns in the context of another? This is where a group by comes in. So let's put a little comment here, group by. So we're going to go car sales. I was going to say PD. I'm used to saying PD. Group by, and we want the make column dot mean. Now, what do you think before we even run this code? Now, I'm going against my only rule here of always run the code first. What do you think this will do if we looked at this? So we've got car sales, which is our data frame. That's up here. We've got this little function here called group by. We know it's a function because it's followed by brackets. And then within the group by, we've got the make column. We've got mean. How to think about it? Doesn't matter. You should write the code out first and press shift and enter and see what happens. So what this is going to do is it's going to group the data frame on the make column, similar to what our crosstab did, but this time we have more columns here. So it's given us the mean values of the odometer of all the different types of makes, as well as the doors. So BMW, the mean odometer rating is 11,179, and the mean amount of doors is 5. And that makes sense because there's only one BMW car. But again, this group by, you could group by almost any column you could imagine, and then call some operation on it as you go. And you can imagine If you had more columns here and you wanted to combine them in some way and view them, you can use this group by function to make sure you only group it by a certain type. Maybe you want only white Toyotas. Maybe that's a little exercise. See how you could group it by only looking at, is there 2 white Toyotas? Yeah, 2 white Toyotas, and then seeing what happens from there. But I just want to show you group by. It's kind of like Crosstab, but for focusing on more than one column at a time. So what's next? All right, well maybe we have a look at some visualizations. Yeah, that's a great idea. So we go car sales, odometer. Let's see if we can do a little plot here. I'm going to call .plot. What do you think this will do? Run that. Beautiful. We get a plot of the different odometer values. So this is what the beautiful thing about Pandas is, how beautiful and how quickly you can get an analysis going. And you might look at a table like this and not really be sure what's going on, especially have lots of rows. But getting a visualization out is a great way to quickly understand what's happening. And we'll have a section coming up on how to make these visualizations a bit more interactive and a bit more prettier with labels and different information here. But what you might find is that if this plot doesn't show up, you might need to run these 2 lines of code. And this is MatPlotLib inline, because you see here, this is generated. This plot is actually, remember how we created an environment and it installed a whole bunch of tools for us? Conda did that for us. When we created our environment, it installed MatPlotLib because some of the functionality, like the plot function in Pandas, depends on MatPlotLib. So behind the scenes, Conda has actually set this up for us. And when we imported Pandas right up the top here, we won't go right back up the top because that'll take a little while. But when we typed in import Pandas as PD, it might have done some work behind the scenes for us to organize this plot. But if it hasn't, you can type in these 2 lines of code, import matplotlib.pyplot as PLT. And this one here, this percentage sign at the front is a little magic function. Jupyter notebooks have different magic functions which do a specific kind of thing. All this is saying is plot our matplotlib plots inside the notebook so we can see them. So if your plots don't show up, make sure you've run these 2 lines of code. So you can type them and put them at the top of your notebook potentially if your plots aren't showing up. So the next thing we want to see is another kind of plot, which is called a histogram. Now, a histogram is a great way to see the distribution. Distribution is a fancy word for spread of data. So you imagine this, most of our odometer readings are between, let's say this is 20-odd thousand up to 100,000. So the reason you can see this kind of curve shape here is because this is where the average about odometer readings fall into. And that these 2 values out here might be considered outliers because they're not within this big clump of values. So that's an easy way to run a histogram on your numerical columns. Let's have a look at the price column. We want to see what different prices of cars we have. .plot. Now why is that? Why do you think that came up? Do you remember no numeric data to plot? Why is that? Let's have a look at the data type, price.dtype. We did .dtypes at the start in one of the other videos. .dtype is just on a single column. So dtype O for object. So it's non-numeric. So our error is non-numeric data to plot. What can we do here? Now we could plot around for a bit and try to get this to work, but let's have a look at how we might research a problem like this. But we might type in how to convert a Pandas column price to integer. Price column object to int in Pandas. Now this is a step you might take if you run into some kind of error. We could always play around with this price column to try to fix it. But I want to emphasize what an actual workflow might look like when you're looking up something. So we've Googled how to convert a Pandas column price to integer, because that's what we want to do. We might click on this, Stack Overflow. I have a column called amount withholds values that look like this. Now what you want to do is when you get to somewhere like Stack Overflow, You want to see if this description of this question matches our problem. So they have a column called amount, which holds values that look like this. That's similar to us, but ours is called price. When I do dataframe.dtypes, it returns this column as an object. Ah, so does ours. How do I convert this to type int? Yes, that's what we want to do. Let's have a look at some of these answers. Okay, this is using regex. What you'll do with these answers is kind of look through them and see which one stands out to you the most. This green tick means that the question asker has marked this as the right answer to help them solve their problem. But sometimes there's other ones, like maybe this one here. I want to use one without regex because regex kind of confuses me. So this has also got 5 upvotes. One of them is mine, previously in doing research for this video here. So what you might do is copy this. And so this, you can see they've started off with amount, which is like our price column, and it's come out like this, which is what we want to do. We want to convert our price column. Let's have a look. Car sales. We want to convert our price columns to something like what our odometer column looks like. We've copied this piece of code from Stack Overflow. We're going to type it in here, but we're going to use it as reference, right? Because we want to get practice writing our own code. So we're going to compare it to what ours is. Let's zoom out one little bit so we can see 2 cells at once. Excellent. So this is saying data frame with a column amount equals data frame amount dot string dot replace. Some interesting combination of code there with nothing as type int. Now that's a fair bit in one go. But let's try replace the parts that we do know to our own. So data frame, our data frame is actually called car sales. So we're going to type in car sales. Our amount column is actually called price. So we'll type in price. And we're going to reassign it to car sales or price. Because what this is saying is, hey, grab the price column and set it equal to this, another car sales.price column, but let's put some adjustments. So this means access the string and replace. Now this little funky combination of slashes, dollar signs, comma, and dots is saying, hey, find these symbols within the price column and replace it after the comma, replace it with nothing, and then change the type with as type to integer. So let's go through that one more time. Car sales price column, we want to readjust it to equaling the car sales price column, so keep the values the same, but access the string and replace the dollar sign, commas, and dots, so dollar sign, commas, and dots with nothing, so this is an empty string, and then change it from a string, so dot as type integer. Whew. Now that was a mouthful, but remember, if in doubt, run the code, shift and enter. Now let's see what our car sales data frame looks like. Beautiful. We've changed the price column to look more like the odometer column. Oh, what's happened here? Ah, the price column has included the cents. So maybe that's an exercise of how to fix that, to not include the cents, because we only want it in thousands, and this has increased it. So now the Nissan, the white Nissan, is now $970,000. But let's see if we can plot it now. Price dot plot. Beautiful. So the plot is incorrect because the numbers are just way too high, but at least we can plot it now. So the next thing we'd look at in terms of manipulating data is looking at this line of code and going, how can we readjust that? So then maybe that's a little exercise you could try. Try to readjust this line of code to not include those last 2 zeros on the end. And now we've seen a few different ways of viewing and selecting data, some of the major ones with pandas. We'll now look at a few more ways that we can manipulate data. So take a little break if you need, go back over the code we've gone through, and I'll see you in the next video. By now, you're probably thinking, my goodness, there is so much to remember. And I'm not going to lie, I felt the same way when I first started. I went through some information on pandas and realized, holy goodness, there is, well, I didn't actually say goodness, I said a different word there. You could probably imagine what word. But I said, there's so much here. How am I going to remember all of these functions off by heart? And the point here is to remember, you don't necessarily need to know all of this off by heart. The only reason I can kind of do this on the fly is because I've had a little bit of practice. Don't forget to always try the code yourself. You can look it up, find things like this. This is part of the research, part of being a data scientist, part of being a machine learning engineer, is learning how to ask different questions. Think about, how can I do this with the data, and then trying to find out. With that being said, let's have a look in this next little section here at how to manipulate data with pandas. So we'll put another little heading like we've been doing. Or maybe manipulating data. That sounds a bit better. Escape. Enter. Press M for Markdown because we're staying communicative. Excellent. And now, again, the beautiful thing about pandas is that if you can think of it, you can probably do it. So the first thing we'll see is manipulating data is some string methods. So Python has a bunch of different string methods like lower. What do you think this will do if we go car sales make dot string dot lower? Let's see. Shift and enter. Oh, it's lowered the string because its data type is an object according to pandas, but it's actually also a Python string. So anything that you can do on strings in Python, you can do on string columns in pandas. There's a bunch of different functions there, but we'll just remember that you can access the string value of a column by doing dot string. We did that above in the price column. We converted it from a string to an integer. Now, if we have a look at our car sales data frame again, what the? Didn't we just lower the string? But it didn't actually save. Now, here's an important concept to remember. It's that pandas requires, if you want to change a column, it requires reassigning that column. So that means we want to set car sales make equals car sales make. We want to do dot string dot lower. There we go. Car sales make, yep, dot string dot lower. Now, what this will do is it will reassign the car sales make column to be a lowered string. So let's have a look. There we go. The string has been lowered. So now all the letters in here are lowercase. You'll probably come across this a fair few times when you're working on different data frames, is this concept of reassignment. What some functions have is that to save you from having to go this column equals this column again, some sort of function, is some functions have a parameter called in place. We'll have a look at that in place parameter along with some missing data. But you might be saying, hey, our car sales data frame doesn't have any missing data. But in practice, in the real world, and when you get real data sets, I've made this one up, right? So I've typed in this into here. Real data sets often contain missing data. So they often look like this. Because you might have someone tracking some records. Ideally, they'd look like this, all the data there. But in reality, when you get a new data set, sometimes it's got a few holes in it, right? Someone hasn't tracked everything correctly, and that's just life. You don't always get perfection. So we're gonna, do you remember how to import a CSV file? I've already exported this one. So we'll go pd.readcsv. We're gonna do tab autocomplete car sales missing data.csv. What this is gonna do is save the car sales missing CSV and import it as a pandas data frame. So all it's gonna do is bring this into being a data frame. Shift and enter. Now this is how pandas describes missing data. N-A-N for NaN. That's basically just saying, hey, I've got no value here. Not a number or something like that. Actually, not entirely sure what NaN stands for, but all I know is that it just means there's no value here. All right, so what if you wanted to fill these missing values with something? So say, for example, we wanted to fill the odometer. So we're accessing that. There's a function called fill NA, which is fill these NaN values. And you can pass fill NA some kind of value, and it will fill these values. So maybe we want to fill up the odometer column with the mean of the rest of the odometers, which in reality isn't a very good practice, but just for demonstration's sake, maybe let's do that, .mean. So what this is saying, oh no, we want missing because this is our missing. Missing. There we go. What this is saying is grab the car sales missing odometer column, this one, and fill NA, fill the missing values with the car sales missing odometer column's mean value. So the values that do actually exist there, we're going to get the mean and fill it. Let's quickly see what that is. Car sales dot missing odometer dot mean. So if we do this correctly, it should fill them up with this value. Let's go there. Beautiful. Now we've got all those missing values. So the third one down is now filled with the car sales missing odometer mean value. We got a few reoccurrences there of all the missing ones. So now if we have a look at the data frame, and this is the practice you'll be going through, right? You'll be making manipulations here, and then you'll be consistently viewing the data frame. So you might do head, but because it's only small, we'll look at the whole thing. Oh, what's happened here? There's still NaN. Ah, this is the problem, right? This is what I was mentioning before, that in-place value that we can use. So let's see it in action. So we could do a reassignment by going car sales missing odometer equals that, and then reassigning the values to being something like that. But what we'll do, we'll look at the in-place parameter so you can see what I mean. So we'll get rid of that. We're going to copy this line of code so we don't have to retype it out. But remember, you should always practice retyping code so you get used to it. Now this fill NA has a parameter, and lots of pandas functions have this in place equals. It's false by default, but we want true. Actually, this is a good time to look at the documentation. So, say we didn't know this fill NA function. What would you do to figure that out? So maybe we go to Google and we go, pandas, how to fill missing data in a column. Working with missing data. Yes, this is a pandas documentation. You get very familiar with looking at these. When you first start looking at this documentation, it can be a bit overwhelming because there's a lot going on. Remember, this documentation is for every single thing that pandas can do, so going through it can take a while. But if we look in here, maybe we want to search for fill. Fill missing values. There we go. Fill NA. Now often it comes with, let me zoom in for you, a little hyperlink to the exact function. Fill NA can fill in NA values with non-NA data in a couple of ways. Excellent. And they give some examples here. We're going to click on the fill NA function and see what happens. So we got dataframe.fillNA, which is what we've got so far. Dataframe odometer, because we only want the odometer column. .fillNA, yep, tick for that. Value equals none. So by default, the value equals none, but it can take a few different values. In our case, our value is the mean of the odometer column. We'll come back. We can see this little in place parameter. It's got a few others, but we're not going to cover them for now. So in place, bool by default, false. If true, fill in place. Note, this will modify any other views on this object, e.g. a no copy slice for a column in a data frame. So if we set in place to true, it means fill in place. Let's have a look. In place equals true. Before we do, we'll take one last look at what our data frame looks like. Still missing values. So let's see what happens. Fill NA in place equals true. Now let's have another look. Go missing. Ah, there we go. So we've filled the values without reassigning. So without typing car sales missing odometer odometer equals that. So that's just a thing to remember. You can always do it this way. Remember how I said Pandas has multiple different ways of doing the same thing? One way to reassign values is to reassign them by putting the exact value you want to replace at the start, or by setting the in-place parameter of a function to true. So that'll really depend on how your workflow goes. Personally, I'm not a fan of the in-place. I like just leaving it by default and then reassigning the value at the start. Let's have a look at one more thing before probably we'll take a little break, as this lecture is getting a bit long. It's if we wanted to remove these missing values. So say, for example, we're happy with filling the odometer column, but every other row that has missing values, we just want to ignore them because missing values aren't going to help us with our data analysis. In truth, they might, but we want to just see how we would get rid of them. Car sales missing. Now there's a function here called drop NA. Now we might just see what happens if we just run that. Drop NA, beautiful. Now if we type in here, car sales missing, what does our data frame look like? Oh, it hasn't happened again. Remember, we've just covered this. What do you think we can do to fix this up? So we might do car sales, drop NA, in place equals true. We'll hit Shift Enter, and we'll have a look at our data frame. Car sales missing. Beautiful. Now, what do you think the value is in maybe not putting in place as true? Now our car sales missing data frame is always going to return those rows with missing values are going to be dropped. What if we wanted to re-access them? We'd have to re-import the CSV. So maybe we do that. Equals pd.read CSV car sales missing. So we'll reset our data frame. We'll have a look at it. This one's going to have missing values. So maybe we create a new data frame. Car sales missing dropped equals car sales missing dot drop NA in place equals true. So what this will do is it returns a copy of our car sales missing data frame, but with dropped values. Oh, I said in place equals true. We have to rerun this cell. That's okay. See, sometimes you make mistakes here. We're going to go drop NA. There we go. Car sales missing dropped. Beautiful. So it's going to be the same data frame, but dropped the missing values. And then what we might do is car sales missing dropped, save this to 2CSV as car sales missing dropped.csv. That way, we can, if we did want to access the rows with missing values, we can from our car sales missing data frame, this one here. Or if we wanted to manipulate our data frame with missing values dropped, we can from this data frame. So that's the important distinction there between using in place or not using in place. All right, we've covered enough on manipulating data in this lesson for the time being. So take a little break, revise over the few functions that we've gone through, have a trial out with in place versus not in place, and I'll see you in the next video. Welcome back. In the last lecture, we looked at a few different ways to manipulate data, especially missing data. We looked at in place. So if you want to perform an operation on Pandas data frames in place, you can set the in place parameter to true, or you can reassign it by using, well, we don't have a reassignment example. Or you can reassign it by setting it to equaling something. Now, we've had enough of working with missing data. How would we create data from existing data? Well, Pandas has a few different ways that you can create data, such as building a new column. Let's have a look at a couple of different ways. Let's start with a series. So maybe we'll comment this first. We'll go column from series. And then we'll create a series called seats column equals PD series. And maybe inside that series, we'll put a few numbers of 5, because a few of our cars have 5 seats. Or actually, all of our cars have 5 seats, but we're not going to fill it up. So we have car sales, seats. And now the way to make a new column, we'll put a comment here. new column called seats. Remember, our car sales data frame is the one we were working with above. So we can view it here. So car sales, new column. Now, it's very similar to how you would select a column to create a new column. But remember, we're going to run the code first before we discuss it. So we're going to set it equal to the seats column, which is that series we've just created. And now we want to view our car sales data frame. Excellent. So we see what this has done. We've got the exact same columns as before, but this time we've now got seats on the right-hand side. So that's created a column on the very right. When you create a new column in Pandas, by default, it appears on the very right-hand side of your data frame. But we've got some missing values here. Okay. That's because our series was only 5 by 5. So it was length 5 with the value 5. I'm getting confused with all these 5s here. So this is just to say, this Toyota white car, $400,000, because we haven't fixed up that price column, and it has 5 seats. But how would we fill this NaN? Maybe we can use car sales with the seats column. We saw this before in the previous video. Fill NA, and we want 5. There we go. Oh, we want in place. Yeah, so we don't have to. In place equals true. Shift, and now we have a look at car sales. Oh, mistake. There we go. All of our cars have 5 seats. Beautiful. We kind of already knew that already. Or maybe some didn't have 5 seats. Now, there's another way to create a column, and that's from a Python list, which is similar to a series. So column from list. Might type in Python list. So we want maybe fuel economy. That's something else you'd want to consider when you're buying a car. These days, you want to make sure that you're getting the best value or the best bang for your buck. Did I spell economy right? No, mix them up. There we go. We want maybe 7.5 litres per 100 kilometres, 9.2, 5.0, 9.6. We're just making these numbers up here. There we go. It's about 5 long as well. And we want car sales. What should we call this column? Fuel per 100 km. That's nice and easy to remember. Equals, we're going to set it to being equal to our fuel economy list. Economy. And then we're going to have a look at it here. Value error. What did we get wrong? Length of values does not match length of index. So that's an interesting error. So maybe we need more values in here. Let's keep filling it up. 8.7, 3.0. This is a really fuel efficient car. See what happens. Still not the same. What do we need? 0, 1, 2, 3, 4, 5, 6, 7, 8. One more should do. 4.5. There we go. So if you want to create it from a list, did that on purpose, wink wink, it has to be the same length as your existing data frame, whereas a series can be different kind of length to what your data frame already is. So we needed 9 or 10 values in here because it starts from 0, because our original car sales data frame was of length 10. All right, let's have another look at a way. What if we wanted to create a column from another column? So as if we wanted to figure out how much this car has fuel it's used in its lifetime. So if this is per 100 kilometers, it's done 150,000 kilometers. Maybe if we divided the odometer column by 100 and times it by this column, we could work out how many liters of fuel this car has used in its whole entire life. Let's try that out. So if we go car sales dot, what's a good name? Total fuel used. Beautiful. Equals car sales. We want the odometer column. Car sales odometer. Maybe we press tab. There we go. Tab autocomplete. Now we want to divide this by 100 because this is fuel per 100 kilometers. And so we could times that by car sales. We want fuel per tab. Per tab? No. I press tab to get fuel per 100 kilometer. Now what do you think this will do? This is going to create a new column because this string doesn't exist in our data frame. It's going to take the odometer column. Another beautiful thing about Pandas numeric columns is that you can perform operations directly on them. And then it's going to divide the odometer column by 100 and times it by the fuel per 100 kilometer column. Let's see what happens. We want to view our data frame. Beautiful. So this is going to be total fuel used in liters, or maybe we could have named that better. If we create this new column by typing in liters, L, it's going to create another column. Total fuel used, L. That's all right. We don't mind that for now. So 11,253 liters. If you did that in one go, that'd be quite expensive depending on the price of fuel where you live. All right, now there's one more easier way to create a column. We can do it from create a column from a single value. Let's do that. Car sales, maybe we want a simple one. Number of wheels equals 4. Because if your car didn't have 4 wheels, you probably wouldn't be able to drive. Now you can start to see how our data frame can evolve over time, right? We've manipulated a few things. Maybe some of these columns aren't very useful in the long run, but it's just an example of how you can quickly use Pandas to change up your data frame. We've adjusted the price column, we've lowered the make column, we've added a bunch of our own columns. These are steps you'll take in a data science or machine learning project, right? Maybe we'll add one more column. We want to know if our cars pass the road safety, and by default it equals true. This is just to give another example of different types of columns. So D types. So yeah, there we go. We've got a bool column on the end now. So bool, true or false. We've got a few ints, we've got a few floats, we've got some object columns, we've got true. So this is how versatile Pandas is, right? You can use many different data types with it. And now what if we wanted to remove one of our columns? It's like this one because it's got the L at the top and that's less confusing than this. We don't know what measurement that's in. You can use the function drop. So we're going to go drop for drop column. So we'll go total fuel used, that's our column name. Now we need to give it, drop requires the parameter axis. So axis equals 1. If you remember the anatomy of our data frame, let's see if we have it here. That's because columns are on axis equals 1. So remember how I said some functions require axis? It took me a while to remember this. But that's all you have to remember, is if you're talking about a column, you're talking about axis 1. So let's do that. Drop, beautiful, car sales. It's still got that. We keep forgetting. I'm going to re-emphasize this point. We need to either reassign or use the in-place method. So we're reassigning our car sales data frame here. Drop, car sales, now we've dropped it. Beautiful. Look at that data frame. That's amazing. All right, so we've seen how to create a few different columns here. We've seen how to drop a column if we don't want it. There's a few more things we want to do for manipulating our data frames, but before this lecture gets too long again, go back. I want you to, if you're going to take a little break, take a little break, but otherwise, before the next lecture, try creating a column of your own. Something can be as simple as you like, but just practice typing out some code like this. Maybe you do a little operation. It can be as fancy or as unfancy as you like, but just practice making a new column of your own, and I'll see you back in the next video. Whew. We have been through a lot, but we're going to persevere. We're going to get through this together. We've got a few more functions to go through. So the next one is sample. Now this is a great way to shuffle your data frame. And what I mean by that is mix up the indexes. So in future videos, when we start applying machine learning algorithms to our data, one of the most important steps is creating a training, validation, and test set. And one of the steps to doing that is randomizing the order your data comes in. Because what you want to avoid is the order that these samples come in may have some kind of influence on patterns in the data. When our machine learning algorithm is learning things, we want it to be as general as possible, so we don't want it to care about the order. Now, there are some exceptions to the rule with time series data and whatnot, but I'm just going to show you this example if you wanted to shuffle rows in a data frame. So let's do car sales dot sample. And now sample is basically saying take a sample from this data frame with this parameter frac is the fraction of that sample. So it's going to be in an integer form. So for example, 0.5 is 50% of the data. So it's going to get 5 rows out of 10. But we, in this case, want to shuffle everything, so we will use 1 for 100% of the data. There we go. So now you can see that the index has been shuffled. So this is essentially the same data frame, just with the order mixed around. Now, the important thing to remember with Pandas is that the information in a row will stay with its row. So row 9, Nissan white, 31,600 kilometers, 4 doors. So the rows stay the same. All that's changing with this function sample is the order that things appear in. And now let's have a look at the data frame again. Oh, silly me, we keep forgetting to reassign. So we want to reassign here, equals. There we go. Now it's going to definitely shuffle the car sales data frame. Or maybe we create a new one, shuffled, because we want to keep the original one in order. So we've got car sales shuffled. This will return a copy, but car sales shuffled will be in a different order to the original car sales data frame. Beautiful. Now, if we wanted to manipulate this shuffled data frame, we could call the same functions we've called before on the shuffled version. And another handy thing about the sample function is that, say for example, you had like a data frame with 2 million rows. Ours is really small, it's only 10, but in practice, you're going to be working on data sets with a lot more rows. Sometimes running functions in Pandas takes a long time on millions of different rows. What you might want to do is practice on only 20% of the data. Only select 20% of data. And now this number could be arbitrary, right? In our case, we've chosen 20%, so that's giving us 2 different rows. If you had 2 million rows, maybe you want to practice on 1% of the data, so that's still 20,000 rows. And so that will allow you to do lots of different experiments a lot quicker than doing it all on 2 million rows at one time. So that's something you'll have to consider in the future in your projects when you're working on larger amounts of data. Is your computer powerful enough to continually run functions on millions of rows? Or do you want to flesh out some little experiments on smaller amounts of data first, and then upgrade those experiments as you figure out what works and what doesn't? Now, if we look at our car sales shuffled data again, we've got our indexes, but they're all out of order. How would we get those back into order? So we can go car sales shuffled dot reset index. This function, as you could imagine, is going to reset the index here. So we want boom. And now there's a way here that you can remove this column. So maybe we go in place. Oh, let's have a look. Did that do that in place? Shuffled. Because by default, the reset index column adds the old index as a new column on the very left. And so we've got order numbers here, but this is the shuffled index that it's made a column. Maybe we don't want that. I think we can get rid of that by in place equals true. Remember, a lot of Pandas functions have the in place parameter. Shuffled in place equals true. Ah, it still has that. Well, the way we figure this out is if we look up the documentation for reset index. Let's do that. Pandas reset index. I don't want that extra index column there. So let's see. Drop. Do not try to insert index into data frame columns. I think that's what we need. Is there an example? Drop equals true. Yep, I think that's what we need. So we want in place equals true. And we want drop equals true. Drop is false by default. Yeah, default false. So this is another example of how you can look up what a function does in Pandas. I just Googled the function name reset index. Again, you won't know these things from the start, but it's not about knowing things off by heart. I don't know everything off by heart. It's about researching different ways that functions work and trying things out. If in doubt, run the code. Let's do that. We still have that there. Maybe we come back up here. We're going to reset this, reset this, reset this. There we go. We had to reset our car sales shuffled data frame. And now we've set drop to equal true. We don't have that index column on the left here. There's one more thing we're going to look at, and that's how to apply a function to a column. So let's say we'll have one more look at our car sales data frame. Remember, this is the process you're going to be taking a lot, is viewing your data frame and then manipulating it, viewing it, manipulating it, viewing it, manipulating it. So it's looking pretty prime at the moment, but we want to convert our odometer to miles. So how would we do that? Car sales, first we have to select it. We can do that by typing in the column name. And then we're going to reassign it. We remembered to reassign it this time. Odometer, kilometers, yep. Now this is the apply function. Apply lets you apply some kind of function, whether it be Numpy or Lambda, to a certain column. So let's just type this in, and Lambda functions can be confusing to begin with. It took me a while to learn them, but we're going to step through this one and figure out what it's actually doing. So if in doubt, run the code. We want car sales to view the whole data frame. Run the code. There we go. Now what do you think this has just done? These numbers have changed. We've got 150,000. It is now 93,776. Well, let's step through this. Odometer column, tick. Odometer column, tick. Dot apply, yep. Lambda. Now lambda is a keyword in Python which is short for an anonymous function. So basically this is saying apply this function to x divided by 1.6. So that's what this is saying. Apply reset x to be equal to x divided by 1.6. Why 1.6? Because conversion from kilometers to miles equals about 1.61 or 09, but I've just rounded it to 1.6. So that's going to divide our number of kilometers by 1.6. Because in this case, x is the values in our odometer column. So this little line here is going to look at this column and go, every time it's going to pick up this 150,000, which is x, and then divide it by 1.6, and then reassign it to that value. So the first column, 94,000 thereabouts. First row, second row, 87,899 is actually about 55,000 miles. So that's what this apply function is doing. And now this is just a simple example of a little Lambda function, but you can get very elaborate with the things you put in apply. We're not going to dive too deep in that for now. Just want you to know that apply is a way that you can assign a function to a column. So you might have written another function somewhere else and then use apply to apply it to a column. Whew. We have been through an absolute mountain of information here. And don't fret, you don't have to know all of this off by heart to begin with. Remember the steps. Try it, run your code. If in doubt, search for it, try again, and then if you're still stuck, ask. In the meantime, before we get into the next section, this is going to wrap up the Pandas section. Check out the resources section for a little bit more documentation about Pandas, some exercises you can try out for yourself. But otherwise, if you're with me, let's jump in and learn a bit more about some other tools that we can use for data science and machine learning.
Hello everyone, and welcome to the Zero to Mastery ML GitHub repo. Now, if you're looking at this in the video that you're watching, and you do visit this URL here, github.com/mrdburke/Zero to Mastery ML, you might notice that this repo has changed. And that's because this course is continually being built and continually being developed. And so as things get added and changed, the folder structure here, the readmes may change, but the work process we're about to follow won't. And now the particular work process we're following is throughout the course, you may notice that we use Jupyter Notebooks a whole bunch because Jupyter Notebooks are the workspace for a data scientist or machine learning engineer. And so if you wanted to download everything in this GitHub repo, you could follow the clone or download little section here. But maybe you want to work on one particular notebook. You don't want everything, so you just want to access one notebook. Maybe it's part of the exercises or the assignment. Let me show you how you could do that. Let's say we want to do the Pandas exercises notebook. We want to work on that. So we'll click on this one, Pandas exercises. We got this URL here. If we wanted to download this one particular folder or this one particular file, we can go click on this raw button. And then what we're going to do is it's going to bring up all this text, but that really doesn't make sense to us. So we'll find a way to make it make sense. We'll go File, Save Page As. And I've got a folder on my desktop called ML Course. And I'm going to save this into my ML Course folder where I'm working on all of the course materials. You may have some sort of folder like this. And I'm going to save it into the sample project folder. Just going to keep it with that file name. So save, beautiful, that's going to download. Then I'm going to open up a terminal. Let's see how we'd access that one particular Jupyter notebook. So what I'm going to do, I'm going to change directory to my desktop and then to my ML course folder, and then again to the sample project folder where I just downloaded. If I press ls, I should have pandas exercises.ipynb.txt, which is this text file here. So how would I access this to work on it? Well, what I'm going to have to do is activate my Anaconda environment. So if I go conda activate, and if you're not sure what this means, don't worry, we'll cover this as well. I'm just showing you how you access one particular notebook. So in a summary, a Conda environment is a collection of tools to work on data science and machine learning projects. So users, mine is stored here, Daniel desktop ML course sample project /env. So it's this little file here. This is what I'm trying to activate. Now if I hit enter there, you'll notice it changes from base to this file path here. Beautiful. And since I have my environment activated, I'm able to access the Jupyter Notebook tool. So if I hit that, this is going to load up the Jupyter Notebook server running on my computer. And you might notice we've got pandas exercises. This is that file we downloaded just before here. Pandas exercises.ipy notebook. And NB is for notebook. And we've got some other ones here that they've got a little different symbol. Right, so this IPyNB stands for IPython Notebook or Jupyter Notebook. Now, how would we convert that into one of these? Let's see. We just open this up. An easy way to do it is just by removing the .text extension and clicking OK. And then hitting Command S, or actually we don't even need to do that. It's going to update itself automatically. We come back to here. Beautiful. You notice that Pandas Exercises IPyNB has now changed to this little book symbol. So if we close this and reopen this notebook, what we can see is we've got an individual notebook downloaded from GitHub and running on our computer. Now, if we check to see if this works, import pandas as PD, shift and enter. Wonderful. So that cell is run without error. So we might delete that because we don't need that. Now, you might be thinking, if you've just gone through this, you might be thinking, wow, Daniel, that's a whole bunch of steps. But don't worry, as you work through the course, you will get more and more familiar with that kind of workflow that we just went through. However, if you'd like to get started far quicker, there is another way. So we're going to come back to here. And one way you can do that is by going into whichever notebook you want to open. And we're going to copy the URL. So in this case, it's just the exact same one as before, pandas exercises.ipynb. And we're going to go to a little tool called Colab. And now this is made by Google. And so the folks at Google had this problem like we're having now. And Jupyter Notebooks, as amazing as they are, can be a little bit hard to get started, get running. And so Google, what they've done is they've created a tool called Colab, which is essentially Jupyter Notebooks in Google Drive. So you will need a Google account to do this little workflow. But what you can do is go to this website here. And what we can see, we've got my Google Drive there, but we've also got GitHub. So I can copy this URL of this Pandas Practice Jupyter Notebook, come back to Colab, go to the GitHub tab, and enter the URL there. And if everything's working correctly, Colab should automatically take all of this information from the Jupyter Notebook on GitHub. Ah, there we go. I should have pressed enter when I hit that in there. So if we come in here, this is the one we want. So there's a little tidbit for you. Make sure you press enter when you copy the link. And there we go. So now we've got our Jupyter Notebook from here in a Google Colab Jupyter Notebook. And these run basically the exact same. They look a little different to a traditional Jupyter Notebook, but this is because they've got Google style. So if we go import, we run that exact same code, import pandas as PD. Warning, this notebook was not authored by Google. This notebook has been loaded from GitHub. You may request to access your data stored within Google or read data and credentials. Please review the source code before executing this notebook. So that's something you might have to, if there are any warnings like that, make sure you read through them. But otherwise, you can notice that this notebook is working perfectly after just copying the URL from GitHub and typing it into colab.research.google.com. And if you want to open something, GitHub, copy the URL, hit enter, and then click on the notebook you'd like to open. In this case, we'll just open the exact same one. And there we go. We can get started running coding nice and easily. So that's just a little tidbit. Remember, if you do refer back to the Zero to Mastery ML GitHub and it looks a little different to what you've seen in this video, don't worry too much. It's just because as we go, we're updating it and continually adding new and updated content.